Draw the graph of y equals x squared plus 2x plus 6 for values of -3 to +2 for x and identify its main features. So here we have a similar style question to our previous video, but here you're given, instead of a linear function, we've got a quadratic. And this is going to create a parabola. So I've got some things set up for me already that you need to be able to do. For instance, I've got myself a table of ordered pairs. And the table of ordered pairs is a little bit more complicated. It looks a little bit more complicated than what you might be used to, where you've just got x and y. But in this case, I've separated each of the terms in my function. As you can see, x squared belongs here, 2x belongs here, and 6 belongs here. I've just separated them out so that we can easily find out what they're all equal to and combine them to find out what y is equal to. So it's the same as just having x, y, but because we have a quadratic with multiple terms, it's just easier to separate them all out and then find out what they're all equal to down the bottom for each x value. All right, so after that, we're going to identify its main features. So the main features are the turning point, the y-intercept, and the roots, which are the x values, the x-intercepts. All right, let's go ahead and start. So again, when you are asked to draw a graph, immediately table of ordered pairs, and I'll start filling in the values. So for when x is -3, or x squared would be just -3 squared, which is +9. When x is -3, 2x would be, or 2 times -3, that's -6. +6, well, that's just always going to be +6. In fact, I can do that for all of these numbers. There's no room for me to substitute x in here. There's no x term. So it's just going to be +6 across the board. All right, let's go ahead and do -2. So when x is -2, x squared becomes 4, and 2x becomes -4. All right, -1. -1 squared is just 1. And -1 times 2, excuse me, is -2. What about when x is 0? 0 squared is just 0, and 2 times 0 is still 0. What about when x is 1? So 1 squared is 1. 2x, or 2 times 1 is 2. Done. Moving on, when x is 2, 2 squared is 4. And 2 times 2 is also 4. There we have it. We've now completed our table of values. We just need to find out what y is equal to, and we just combine all those terms. So 9 take 6 is 3, plus 6 is 9. That's for when x is -3. When x is -2, 4 take 4 is 0, add 6 is 6. What about when x is -1? We get 1 take away 2, that's -1, add 6, +5. I'm just going to write 5 here. All right, what about when x is 0? It just becomes +6, or just 6. And when x is 1, 1 plus 2 is 3, plus 6 is 9. And when x is 2, you get 4, plus 4 is 8, plus 6 is 14. All right, so our y values are 9, 6, 5, 6, 9, and 14. Let's go ahead now and plot our coordinates. Now, just to remind you, our coordinates are our x values and our y values for each of these columns. So again, what we've done is we've just plugged in each of these numbers into the expression or into the function above, but we've split them up into the individual terms here, x squared plus 2x plus 6, and we've plugged out these numbers, and then you just combine these numbers together and you get what y is equal to. Okay, that's all we've done. All right, let's go ahead and plot our coordinates onto our Cartesian plane here. Notice that our Cartesian plane doesn't have a negative y line, like a negative y-axis like this. We don't have that, and I've done this question before, so I know we don't need it. And the reason why we don't need it is because, as you can see, our y values are all positive. So we're never going to have to go down here. So that's why I've just gotten rid of it. You don't have to do that. You can set up a normal Cartesian plane. That is fine. All right, let's start plotting some coordinates. All right, -3, 9. That's -3, 9. Next one, -2, 6. Next one, -1, 5. Next one, 0, 6. Next one, 1, 9. And next one, 2, 14. Okay, now we've plotted our coordinates, we can go ahead and connect our coordinates, not with a straight line, because we have a parabola, it's going to make a U shape, but with a curved line. So I'll go ahead and have a go at this. It might take me a couple of shots. So that's close enough, I'm happy with that. As you can see, it makes a U shape. Now, could you predict where our next coordinate would be over here? Where would you think it would be? Perhaps it would be 14 and -4. You'd be the decider of that, but we don't need that because we've now drawn our function. We've graphed it between values of -3 and 2. So we now need to turn to our features now. So our features are our turning point. Now, a turning point is the point at which our graph goes from a positive or negative slope to the other positive or negative slope. Let's go ahead and zoom in. The turning point, which I like to call the vertex, is essentially the corner of the parabola, the edge. So it's going to be here. It's the point at which this parabola goes from, and I'll use a different color. I'll go with red. It's the point at which the slope goes from a negative slope to a positive slope. I hope you can see that there. Currently, our slope is negative, and all of a sudden, it transitions here to a positive slope. When you go from negative to positive, we call that a minimum. So our turning point is at a minimum at the position, and this coordinate, do we know what this one is? -2, 5. So minimum of -2 and 5. Okay, so let's zoom back out. Oh, I apologize. It wasn't -2. It was, as you can see, -1. So let's go ahead and adjust that. We have a minimum of -1, 5. So that there is our turning point. Let's go ahead and write that into our answer. So turning point is a minimum at -1, 5. Done. Now, where's our y-intercept? Our y-intercept, let's again zoom back in. For all functions, for all graphs, your y-intercept is always the coordinates or the position where x equals 0. So let's go across on our x-axis. There's x is 0, and then we just keep going up until we find the position where our line crosses the y-intercept, the y-axis, and it's right here. It's +6. Okay. So the coordinate is 0, 6. The y-intercept is 6. So 6. Now roots. Roots again are our x-intercepts. Do we have any x-intercepts here? We don't have any x-intercepts. Our line does not cross through the x-axis. Here's our x-axis here. If it was something like, and if I was to maybe, I don't think I can do this. No, I can't manipulate the whole graph. But if I could show you what it would look like if it was down a little bit further like that, therefore, we would have some roots here and here. But that's not the case. Our parabola is sitting well above the x-axis, so there are no roots. So you would just write no roots.